Hey guys, this week we're going to start our energy unit. I hope that you have heard of potential and kinetic energy before. If not, so we're going to review and kind of get you to know this energy unit is kind of fun-filled. I love teaching energy. Physics is my favorite. So anything I get to do with physics and show you and help you understand how the world kind of works is always so interesting to me. But to start it off, we're going to learn about the two categories of energy. So it's potential and kinetic. What we'll be looking at is compare and contrast potential and kinetic energy. So energy, I'm sure you have heard, is the ability to do work. It's the ability to move or cause change in matter. The two types of mechanical energy is potential, which is stored energy, and kinetic energy, which is moving energy. So potential is stored, meaning there's a possibility it can be transferred to kinetic energy, but it's mainly being stored. So when it has the ability to move, it's potential. When it's actually moving, it is kinetic. So potential energy is stored energy in an object due to its position. So that means like due to its position based on ground level of Earth. If you look at the picture with the really tall rock up at the very top in the middle, it has the greatest potential energy because it's higher up, so it has a longer way to move and start moving down towards the ground. So it's ready to be used but not being used just yet. It can be transformed into other types of energy. We measure energy in what we call joules. Distance, which is usually the height, so how high up something is, and the mass, meaning is it big or is it small, determines the potential energy that an object has. It's found in all objects. Even when we are sitting in our chairs, we have potential energy. So it's found in everything that's above the ground level. So if we look at ball A and ball B, which ball has the greatest potential energy? So how we measure the greatest or the potential energy is the amount of potential energy is determined by its height, so how high something is, or its mass, if it's a bigger mass or not. So the higher an object, the greater its potential energy. So which ball here has the greater potential energy, ball A or ball B? So just like we said with the height, the greater the height, the more potential energy, the greater the mass, the greater potential energy. Now we have a potential energy that's elastic. So elastic potential energy. Which bow has the greatest elastic potential energy? So which one do you think has the greater elastic potential energy? The energy stored in elastic materials as the result of their stretching or compressing. So as far as you can stretch something, a rubber band back, so you have a rubber band, and the farther you stretch it, the more elastic potential it's going to be. If you have a spring and you compress it to where it wants to come apart, fly apart, then the closer you get the coils, the tighter you push it down, the greater the potential energy you have. So the amount of energy stored is related to the amount of stretch applied. Just like I said, the more stretch, the more stored energy. So after potential energy, now we're going to move on to kinetic energy. Kinetic energy is the energy in motion. When an object's in motion, it has kinetic energy. It's formed or caused by motion. It can be transformed into other types of energy. Like if a rock slowed down, then it still has potential, it goes back to potential energy. It's also measured in joules. Speed and velocity and mass determine its measure. And real quick, before I move on, speed, you all know how we calculate speed. You know, miles per hour is usually what you see in a vehicle. Velocity is not the same. Velocity is speed plus direction. So if I was saying speed, it'd just be like 65 miles per hour. But if I wanted velocity, it would be 65 miles per hour north. So that's how you determine velocity as well. So found in all objects, the kinetic energy is the amount of energy is determined by its speed, velocity, and its mass. So the faster an object moves, the greater its kinetic energy. Which object has the greatest speed? Is it 20 meters or 10 meters? Kinetic energy, the greater the mass, the greater the kinetic energy. Which ball has the greater kinetic energies? Alright, so we're going to look at the transformation of energy in a bouncing ball. So we're going to look and see where it goes from potential to kinetic. It's transformed. If you think of energy, energy is never lost. The law of energy is never lost. It's not created or destroyed. It's just transformed. So we're going to look at the bouncing ball. Several energy transformations happen when a ball is dropped on a surface and bounces up again. So when you hold the ball up before you bounce it, it has its maximum potential energy because it's not moving, it's being held up. It doesn't have any kinetic energy because it's not moving. Now when you drop the ball, potential energy starts decreasing because now it's starting to move. And the kinetic energy is increasing because it's in motion. When it hits the bottom to bounce back up, the potential energy is 0 and the kinetic energy is at its maximum. That means it's moving with all its force. And then at the very end, when it starts to come back up, that kinetic energy starts changing to potential energy because it's getting ready to stop when it gets back up. Same thing if you look at a pendulum. If you've ever seen a pendulum, it could be like it's a swinging circular device that's it can be found in grandfather clocks. A lot of shows used to show hypnotism with a pendulum. It's just when you swing an object back and forth. So several energy transformations happen in a pendulum. That's why they're so good to show potential and kinetic energy. A is where potential energy is at its max because you're holding that ball up in the air before you let it go, kind of like a swing set. If you pull that person back up and before you let them go, it's at its potential energy maximum. When you let it go, it starts to transform from potential energy to kinetic energy, and when it gets to the middle, where B is, that's when kinetic energy is at its max, and then the potential energy is at the minimum. When it starts to go back up, then it starts to slow down. So that's when the potential energy starts to become maximum, and the kinetic energy, because it stops for a split second, becomes very minimum. Look at this roller coaster. It shows transformation of energy as well. So if you're on a roller coaster and you know how energy works, is we know the potential energy is its greatest when it's above at the highest. So where on the roller coaster, would the potential energy be the greatest? The reason being, the potential energy had to be the greatest at the first hill is because it gives it enough energy to start with so that it can finish the course of the whole roller coaster. And if you look, it goes up to the tallest hill, and when it's just about to tip over, it's at 100% potential energy. Then as it's going down, it starts going 50-50 because it starts to speed up. Then at the bottom, it's at its fastest, so it's 100% kinetic energy. And then when it starts to go back up a hill and it slows down a little bit, it starts to transfer back to potential energy. So let's look at this. Decide if each situation is an example of kinetic or potential energy. So standing on the end of a diving board, is this potential or kinetic? It is potential because you're standing there, you're not moving. Falling from the top of a ladder. Kinetic because you're falling, you're moving, you're in motion. A rubber band pulled back as far as it can go. It is potential because it's not released to go back to its natural form. Water in a lake behind a dam. It is potential. Baseball just before it is released by the pitcher. So just before that pitcher releases the ball to be thrown, is that potential or kinetic? It is potential. So I want you to be thinking about potential and energy demonstration to the class. When you are here and in person, and also one of your assignments will be to describe a way that there is potential and kinetic energy in your everyday life. Be able to point out the point in your demonstration when potential and kinetic energy is at its greatest and least, and then you will share this information with me. Or if you are in person, you'll share it with the class. If you have any questions with the work this week, please email me. Also, we will be starting the energy unit, so I need you to be thinking about supplies that you could bring in for a solar oven, like boxes or aluminum foil or plastic wrap, tape, any of that you just have at your house. I'm not asking you to go buy any that you would like to donate. That would be great. Please contact me at the school if you need me. Email me and ask to get on a Google Meet. I will help you in any way I can. Thank you.